Everyone, and welcome. In this lecture we look at mean and Gaussian filters. As usual, we start by importing the libraries and modules that we need. I copied this from the previous lecture, and in addition we'll need to import a couple of libraries. Let's first import the filters library. So from skimage import filters, and there's another library we need to import. It's called the Convol. Let's do that also. From scipy .nd image, we'll need to import Convol. We'll use those two later on. Okay, and let's start by creating zeros arrays and then create an image from that. So we'll use numpy zeros method, np.zeros, and let's create a 10 by 10, and we'll use the float data type, and I'll save this in a variable called square. If I print our square object, we see that it's an array of zeros, 10 by 10. And what I will do next is index some part of our array. Let's index the middle part of this arrays, and then we'll set the values to be equal to 1. So we have our squares object. We saved it as square. We have our square object, and let's index, let's say 327, then 327. And once we index that section, we'll set it to be equal to 1. Now, if we print our square object, we see here the middle section is 1, right? 1, 1, 1, 1, 1, 1, and so on. What we'll do next is plot our square object. Okay, similar to what we did in the previous lecture. We'll use the matplotlib subplots method. And then we can call the plot method on our square object. Oh, that's not what I intend to do. Let's call the imshow method, imshow, and then pass square. Okay, this looks much better. So here we have a white square inside this black square. Next, we'll apply some mean filtering and convolution. So to show you what that is, here in Wikipedia, you can type mean filtering or image processing. Here I have a result for kernel image processing. So a kernel or convolution matrix or convolution is useful for blurring, sharpening, and so much more. This is accomplished by means of convolution between a kernel and an image. So here, depending on the element values, a kernel can be used for a wide range of effects. Okay, these are the different effects. You have your image by passing different kernels. You can manipulate your image. Okay, that's what we'll look at. We will see. We'll look at mean filtering and Gaussian filtering. Okay, and there's a method known as convolution. We'll apply that method. What's convolution? Convolution means it's a process of adding each element of the image to its local image weighed by the kernel. Okay, you can read more about convolution here. So you take your kernel, and for each element in your kernel, you multiply the position of each kernel by the pixel, and you multiply each value corresponding to the pixel value, and you apply that to every pixel in your image. Okay, that's the method that we'll use. Okay, you take your kernel on a certain pixel, and then you multiply the pixels by the values in your kernel, and then you sum up all of the individual results, and then you replace it with the result. That's what convolution means. And scipy has a method known as convolve. and it will do that for us. So you can read more about it here. Let me go back to the notebook. And the next thing we'll do is create an array of ones and then use that as our mean filter. So I'll save it in a variable called mean, and let's create an array of ones, np.ones, and then let's create a 4x4 array of ones. Next, if we print our array, it looks like this: 4x4, 1 1 1 1 1. Since it's an array of 1, 4x4, to calculate the mean, we can simply divide this by 12. So now, if I take my mean object, paste it here, and divide it by 12, and let's print our mean object again. Now, instead of an array of 1 1 1 1, we have 0.08 0.0833. That's because we divided it by 12 to calculate the mean for each of our NumPy array values. What we'll do next is apply our convolution method. We'll take this mean array and then apply it to our square arrays. Okay, we'll apply it for that by using the convolve method. If you guys remember, at the beginning we imported convolve from SciPy, and this convolve takes two attributes. Let's pass those. So we'll call the convolve method and then pass our square object and then the mean object that we created. And let's save this in a variable called smooth convolve. Okay, and next let's look at the Gaussian filter. So if you go to scikit-image documentation, you will see this Gaussian image, this Gaussian method, and then it takes the attributes image, sigma value, output, modest, and cval. You can read more about it here, and there are some examples of Gaussian filter. We'll try to look at that here. So Gaussian filter is similar to the mean filter, but the only difference is we saw that when we use mean filter, it takes all the values in the neighbor equally, right? It applies the mean by taking each of the values, whereas the Gaussian filter doesn't weigh all the values equally. Okay, and the pixels that you take closer to the center weigh more towards Gaussian filter. Okay, so pixels closer to the center contribute more for Gaussian filtering compared to pixel values towards the end or away from the center. That's the difference between Gaussian and mean filters. So what we'll do is we already imported filters, and we'll call the Gaussian method and pass our square image and some sigma value. Okay, this is the standard deviation value for our image. Let's do that. So we have filters that Gaussian, and then we'll pass our square object and a sigma value. Let's pass a sigma value of 1.2, and let's save this in a variable called smooth. Okay, now that we have our mean filter and Gaussian filters, let's try to visualize it. Let's try to plot it. So for that, we'll call the imshow method, plt.imshow, and let's first see our square image. So this is our square image. Next, let's plot our plt.imshow, and let's plot our smooth convolve. Run it. So this is what it looks like. This is for our mean filter. And finally, let's plot our Gaussian filter. plt.imshow. Then we'll pass our smooth object that we created here. And that's what it looks like. Okay. Here we have our original square object. And once we apply the min method, the min filter, this is what it looks like. And after applying the Gaussian filter on our original square image, here is what it looks like. Again, the difference between Gaussian and min filter is that when we use Gaussian filter, values closer to the center way more compared to values away from the center. Whereas in min filter, each pixel weighs the same, contributes the same. So that's what I wanted to show you in this lecture. So read more about it. It can be a little confusing, but I just wanted to quickly show you about min filter and Gaussian filters. And convolution is very important in this method. Here we have a few examples, and you can read more about Gaussian filters in the documentation here. Okay, it takes the image attribute. You can pass different sigma values. For our example, we passed a value of 1.2. You can pass other values, let's say 0.3, 0.4, and then compare your result. So sigma is the standard deviation for your Gaussian kernel, and the standard deviation is given for each axis as a sequence. Okay, thank you everyone, and see you at the next lecture.